If you all want to do something really cool, civic-minded, the Blood and Tissue Center need O positive blood really badly. So I'm thinking about going on Friday and donating blood. So if you all can, that'd be really great. They need O positive really badly for the stuff we had happen on 6th Street this weekend. So if you can, that'd be great.
I don't know what happened. I just got an email from ACC.
Bad.
Is this at One Right Tissue?
Huh?
Is this One Right Tissue or ACC?
No, this is the blood. This is We Are Blood. They're the Blood and Tissue Center for Central Texas. The Red Cross does it also, but I don't know where they are. All right, come on over. So today you're running 4 tests, and there's a few organisms you're going to test. So the grouping of these tests are known as MVIC. I for indole, M for methyl red, V for Votes Proscour. The little I means nothing, it's just so it makes sense when you say MVIC, and the C stands for citrate. This is what SIM looks like. There are 3 different substrates in here, 3 different test results that we're going to get. The first one is whether or not hydrogen sulfide gets produced. Hydrogen sulfide is a gas. It gets liberated when protein are breaking down. And in here, there's a little bit of ferrous ammonium sulfate, also known as iron. And that will react if hydrogen sulfide gets produced, and it'll produce a black precipitate. And the black precipitate, because it's a gas, will be throughout the entire tube. The second attribute is it's a motility medium. So how are you going to inoculate it? With a straight needle, go about 3/4 of the way down and right back up, is motility. Now there's no indicator in here, so you're going to have to look where you inoculated and see if it's growing only at the site of inoculation or if it's growing away. Okay? These 2 tests will be confounded by, or the motility will be confounded by the hydrogen sulfide, because if hydrogen sulfide gets produced, it's going to look like it's growing throughout the tube. It's the gas. For the scope of this exam, this practical only, if it's black, we're going to say it's mold. Okay? But there is 2 organisms that produce hydrogen sulfide that are not modal. So when you do your unknown, you're going to have to do a separate motility test. But for this practical, so we don't have to do another test, we're just going to say it's mold if it's black. Okay?
You said mold or mobile?
Motile.
Neither.
Okay. So the 2 things, you inoculate, you come back in 2 days, Thursday, and you can see those 2 things really quickly. If it's black, it's H2S positive. If it's not black, it's H2S negative. If it's only going to the site of inoculation, it's non-modal. If it's fuzzy away from the site of inoculation, it's modal. Okay? The last one is there's the reaction there. There's, oh, I'm sorry. That's tryptophan. I wrote it twice and I didn't read it. This is tryptophan. I'm sure if you took a picture, but you take another picture now, it's showing correct. Tryptophan can be broken down enzymatically by an enzyme called tryptophanase. It's 3 enzymes. But if it breaks it down, it produces indole, produces pyruvic acid or pyruvate, and it produces ammonia. We don't care about the pyruvic acid or the ammonia, but we can test for indole production colorimetrically. So you're gonna after this has been inoculated and you look to see if it's modal or if it's H2S positive, you're gonna add 5 drops of a reagent called Kovacs reagent. And then you're going to give it a little shake. If it's going to be positive for the breakdown of tryptophan to indole, there's going to be a red lake that actually will form at the meniscus. It has a little different viscosity, so it's going to hold that position for, and eventually it'll dissolve, but it'll hold that position for hours. Okay? And then I'll explain how you evaluate this when we come back on Thursday. Okay, you're only going to add the organism today. You're not going to add any of the reagents. Okay? The next two tests are exactly the same. They're two tubes that are exactly the same, but we're going to treat them differently. We're going to label one MR and one VP. The MR VP are always run in tandem. They're always run together. Okay? The glucose is the principal substrate. You're going to inoculate this with one set, one MR, one VP for E. coli, and then another set, one MR, one VP for Enterobacter coli. You're going to come back in 2 days on Thursday, and to the one labeled MR, you're going to add 5 drops of methyl red, and if it turns red, then it's positive for acidic conditions. Okay? You're still going to run the other one. The other one is called the VP. It tests for neutral end products. So here, on Thursday, you're going to add 15 drops of potassium hydroxide, 8 drops of naphtha. But it takes forever. So we're going to add a catalyst. The catalyst is called creatine. We're going to add, or creatine, or whatever you're going to call it, creatine. Okay. So no, it's okay. So you're going to add it in here. It's going to speed up the reaction. It's still going to take about 5 to 8 minutes. But it's going to turn a deeper red. It's going to be like burgundy from A&M. Are you with me? That means it's positive for the production of neutral end products. Okay?
So when it turns burgundy, it's positive.
For neutral end products. Okay. So now look at my little chart over there at the very end. You see that positive MR but negative VP means you have an acid end product, right? Negative MR, positive VP means you have a neutral end product. If both are negative, it's not positive, it's not neutral, it's basic. And if both are positive, it's usually going to be that you have an error. But you have to be careful. We have one organism that produces slightly basic conditions, and the tests aren't sensitive enough to discern it. It's going to come up positive both of them. So when you're doing a null and you see that they're both positive, first of all, think it's probably an error, but then look at the other results and see if it matches up. Because on the table you'll see 2 positives, and then you'll say, "Oh, I have this over there."
So it's user error.
Huh?
Is it user error? Why,
No.
Why it would be 2?
Oh yeah. So if it's any other organism, it's user error. Something
Okay.
happened. Usually they contaminate with some other organism. Okay. Then the last test is the easiest one of them all. Does anybody have a needle close by that I can borrow? Will you grab a needle for me, please? Thank you. So this is called citrate powder. And we're looking for the ability of a microorganism. Thank you very much. We're looking for the ability of a microorganism to use citrate as its only source of carbon. Okay? You're only going to use 2, so you need 2 of these. One of them you're going to put E. coli, and the other one you're going to put Klebsiella pneumoniae. The way you inoculate this, and any slant from now on that's differential or selective, the way you're going to inoculate it is you're going to take the organism aseptically, take the needle and go in and then touch the bottom of the slant. You're going to streak the slant and then stab the butt. This is the butt. Okay? So once again, you're going to go in, you're going to streak the slant and stab the butt. Okay? You can do this with a loop or a needle. We're not looking for any pattern. We're looking for the things that might be produced metabolically. Okay? Anybody any questions? You'll come back in 48 hours Thursday, and you don't have to do anything else to this one. All you gotta do is look at it. If it's green, it's negative, or yellow, it's negative. But if it turns blue, it's positive. Because when the organisms break apart citrate, they release ammonia into the environment. When ammonia is released into the environment, does the pH go up or down? Up. Because ammonia is basic. It's going to cause the pH to go up. Therefore, a blue slant is an indication of a basic reaction, which is positive for your breakdown of citrate. Okay? All you're doing is inoculating. You're not adding any reagents today. Once you do that, you put them back on the red tray and then clean up, and you all can go home. We're done.